Hello there, my name is Kaylynn Watson. I'm a software engineer at Focus Labs. I've been doing a lot of diving into developing around AI, both using AI to help me write code and using code to leverage AI. Um, when you're getting into building AI, there's a lot of tools or frameworks out there, and it can be very overwhelming. I would highly recommend LangChain as your framework of choice. They have recently published a framework called LCEL or LCEL, LangChain Expression Language, that I had the pleasure of working with this past week, and I'm really excited about it. It's the smoothest, most intuitive framework that I've worked with so far, and it exposes the right amount of details that you as a developer need in order to have the biggest impact on the quality of your application. So today I'm going to walk through maybe some of the basics of LCEL, LCEL, and hopefully you'll be able to use this as a starting point to dive into your own application. I'm really excited to make this a little bit more accessible, so that's why I'm here. So I'm on the LangChain website. I would recommend coming here and going to the docs. I know it's not glamorous to read the docs, but they're actually pretty good. So I would start with the get started. This will talk through what is a chain. In my words, a chain is a bunch of different components put together in a way that makes AI just that much more magical to the end user. We've all fiddled with ChatGPT and we've seen how it hallucinates or makes mistakes. And so there are a lot of different techniques that a developer can use to make these AI driven apps more accurate or more useful. So chains are a way that we can put these basic components of logic together and use a like Linux pipe type of pattern. I think it's really intuitive. So yeah, that's LCEL, and that's what a chain is. Then I would recommend coming over to this interface page. This is going to be your most referenced page, most likely. Really pay attention to the different components that you have for your chain and the input and the output type. So again, think about this as a Linux pipe where the output from one component needs to feed into the input of the other one, and there's not quite type safety, so it's something that you have to, as a developer, make sure that you're paying attention to. And then they also call out exactly how do you run this. How do you say go? You use either a stream, .invoke, or .batch based on your use case. For now, I'll just talk about .invoke, but what's super cool about this is that streaming and batching and asynchronous support is like right out of the gate. It's right there, and it won't take a lot of work to add in. Then they have a lot of how-tos around running parallelize. They have a lot of support around running custom function. They even have fallbacks. They have the ability to branch your chains based on inputs. You can bind runtime arguments. So an example here is maybe sometimes you want to run with Anthropic, or sometimes you want to run with Gemini, or sometimes you want to run with OpenAI, depending on what question the user asks. So you're able to route depending on what offers the best results or has the best cost efficiency, whatever works best for you. Then they have a bunch of cookbooks here, a lot of good examples. And then in the modules, they go into the big details of modules. So they talk about, what's the difference between an LLM and a chat model. You can talk about different retrievals for RAG type applications. You can even work with agents. And they have a bunch of memory types here. So lots of really good examples here. And what's awesome about their documentation is that there's not a lot of words, there's a lot of code. So I would highly recommend checking them out. I started with RAG. The example application that I wanted to upgrade is a knowledge base for the company focused labs. Kind of just as an example of what if you were a potential employee or a potential customer and you wanted to learn more about what Focus Labs was as a company. This would be the application to do so. So that's a retrieval augmented generation type application. So all right, that's enough about documentation. Now let's get into like, okay, how do I actually start building this? For me, I'm a very visual person. I really like whiteboards. And so I immediately reached for a quick Miro board, trying to drive out the question of like, all right, so there's lots of cool documentation here. I want to keep myself from getting into the weeds of the code and getting lost. So where am I trying to go? And thinking through this, I was like, well, I know I have a question from a user. I know I need to retrieve the document somehow, and I need some kind of answer. So these will be the three main components in my chain. And I know that question needs to, the outputs of question need to go into the retrieved documents, and the outputs of retrieved documents need to go into the inputs of answer. So went over to RAG, and you can see you have the retrievals here. We have this prompt, which is like that question, and then we have the answer or this model. And so there's this quick chain that's like immediately present. You're able to run with this and keep going. As much as I love reading documentation, I say that a little facetiously. I used Jupyter notebooks to get my hands into the weeds. And so I came in here and loaded up these code blocks, and I was able to very quickly see and trace through that input-output schema thing that I was working on. So you can see here, this is where I ended up. This is not where I started. So there's some code here that may not make a whole lot of sense, but you can see that, let's start backwards. Let's start with the answer. So the answer, I need docs, and then I need whatever is in final inputs and answer prompt. Final inputs has context, question, and standalone question. And the answer prompts is right up here. I'm blind. Answer prompt is right here. And so the answer prompts, you can see has context and question. So I know that I'm going to need context, question, and standalone question to come out of retrieved documents in order for that to match up. And so, yeah, I was able to play around with this, get this spinning up pretty quickly. And what's really awesome about the chain is it's really easy to add a component. So you can see I added this loaded memory here, and that came from going back to my architecture diagram. I was like, okay, cool, I can get questions, but what if I want conversation history? I want this like memory to exist throughout the conversation. Then it was like, okay, so I need conversation memory needs to start at the beginning, not necessarily at the end, which is like where I've seen it before, because I need the conversation memory to feed into the question. Because when I have the question, I'll ask the LLM to, given the conversation memory, rephrase the question to be a single question. It's a little bit more elegant of an answer. And that will go into the retrieved documents and the actual answer. So again, very rough whiteboarding, but for me, helps keep in mind where I'm going. And so I was able to whip that up with memory, loaded memory. Again, going back to the RAG, they have this conversational with memory and returning source documents just right here in the code. So it was very intuitive, very easy to just plop that in and test it out for myself. The one thing I will call out that did trip me up is you do have to save your memory after you get your answer. This doesn't happen automatically, and they have a note here that it will be improved in the future, but for now you do need to save it for yourself. So that is something that tripped me up a little bit, so I'm going to specifically call that one out. But going back to my code, once I was happy with the Jupyter Notebook, it was good enough. I was able to throw it into regular Python code. I used a class type architecture because then I'm able to see a chain that exactly matches that architecture diagram whiteboard that I had from before. And I really liked that. It helps me keep track of a little bit of the variables and just keeps the code a little cleaner. I also really love how all of my prompts are really accessible. Before, they would be kind of embedded and you'd put a prompt inside of a prompt inside of a prompt inside of a prompt, but now they're all exposed, and so you're able to tweak them. Prompts are really, really powerful when working with AI. Changing a couple of words will drastically change the behavior of an LLM. So I love that it's right here and it's really intuitive and exposed. And I'm sure you've heard me say these terms a bunch of times already, but I'm going to say them again because I'm really excited about them. But yeah, I was able to throw this in a chain, and then I threw it in a query service because I'm using a REST type architecture. So I'm able to throw them in here. And then I'm able to see these intermediate steps of chat history in the standalone question. I'm able to see that and verify that it's there and it exists. And that made debugging really, really easy. So when I was like, hey, chat history isn't there, I was able to print out chat history and be like, oh yeah, indeed, I'm not saving it correctly. So that's where that note from before of saving memory is really helpful, where it came about from. But yeah, so in closing thoughts, LCEL or LCEL is really powerful and really intuitive. It's intuitive, so it's easy for a beginner, but you're able to stay with it and tweak a bunch of components or variables or little knobs. So you're able to grow into this framework. Whereas opposed to like maybe the OpenAI assistants, it's easier of a way to start, but it's a little bit obfuscated and abstracted framework, so you're not able to do as much tweaking as you may want to. So yeah, thanks for joining, and I'll catch you all next time.